In this section, Logic and Proofs, we will learn to prove propositions and to prove compound statements. We'll be able to use these tools then throughout the course to prove facts. So, therefore, this section is very important. The first part is propositional logic. A proposition is a sentence that it is declarative and you can deem that sentence as true or false. If I tell you, for example, Toronto is the capital of Canada, this statement is declarative and it can be assigned a truth value. It could be false or true. In this case, it is false. We all know Toronto is not the capital of Canada. Normally, in mathematics, we're going to be using variables to denote propositions. So that's going to simplify the way we write down things, and it will make our lives much more easier if we use literals. Normally, if a proposition is true, we are going to use capital T and capital F for false. Also, we use ones and zeros. 1 is typically true, 0 is typically false. And that's the convention we're going to follow. You can imagine this convention obeys computer science and the way circuits are considered the truth values, true for 1 and false for 0. So we'll follow this convention. A compound statement can be formed if we use connectives. So the type of connectives that we're going to study today are the ones that we use, some of them in natural language. So when we are communicating in English, we are using these connectives. The first of them we're going to study is the negation. The negation is denoted using this symbol. If you use that symbol, that means that you are negating whatever proposition P is saying. So if the statement P is Toronto is the capital of Canada, if you negate this statement, then you can read this as it is not the case that Toronto is the capital of Canada. Now, if you negate something that was originally false, it becomes true, and vice versa. If I tell you it is not the case that Toronto is the capital of Canada, that statement becomes true. Another connective that we use in our daily lives is the and the or. So these connectives are denoted using these two symbols. So just like when we talk in English, for a compound statement using an and, for that compound statement to be true, both of the propositions have to be true as well, right? If one of the propositions is false, the whole statement becomes false. If I tell you Toronto is the capital of Canada and Ottawa is the capital of Canada, the whole thing is false. Even though the second statement, the second proposition is true, I use an and connective. So I'm kind of saying that both of the statements are true, but that's not the case. The first statement that Toronto is the capital of Canada was false, so the whole compound statement becomes true. False, sorry. For the or, as long as one of the two variables, P or Q, is true, then the compound statement is true. If I tell you Toronto is the capital of Canada or Ottawa is the capital of Canada, if you're going to make it sound more natural, you can say Toronto or Ottawa, either Toronto or Ottawa is the capital of Canada. That is true. So because one of those two statements is true. But if I tell you Toronto is the capital of Canada or Calgary is the capital of Canada, both of those propositions are false, so my whole compound statement is false. Another connective that we don't really use in English, or actually we do, but not so often, is the exclusive or. This is if we were to map this to our natural English language, we would say that the exclusive or is the equivalent of saying either or. So when you're talking in English and you say either or, you're and I hope you would be referring to an exclusive or. An exclusive or connective makes the compound statement true only when exactly one of the propositions is true, but not both. If both of them are true, then the compound statement becomes false. And of course, if both of them are false, the compound statement is false. So if either P or Q, but not both, is true, then the whole thing is true. Now, you can see that these connectives, the and, the or, and the exclusive or, they're relatively simple to map mentally. So you can mentally kind of see, assign values to P or Q, and then do the calculations in your mind and come up with an answer. So what's the truth value of the whole statement is not so difficult to compute. But what happens when you have more complex connectives, as we will see, or when you have more complex compound statements that consist of more than two propositions? Then you make use of a truth table. Truth tables, we're going to be using them throughout this section during the synchronous session of this course. Here we have an exercise. We'll do that during the synchronous. And then let's move on to the next connective. It's a conditional statement. So it's an implication. The implication is a conditional statement. It's also a connector. So you can create compound statements. And this is what you are using really when you talk and you say if P then Q, if P, Q. So P implies Q, you use this arrow. The direction of the arrow is very important, as we will see. And all these different ways of saying P implies Q are equivalent. Note here that some of them might be confusing. For example, Q is necessary for P. See the inverted position of P and Q? This still means P implies Q. Q if P, this means that P implies Q. So be very careful with this, because they might be confusing when you are translating from plain English into variables. There might be mistakes here. That's a very common mistake that I've seen. So there's a red flag. Make sure you know these ways of talking about the implications. So the converse of an implication, P implies Q, is Q implies P. So for an implication example, if I tell you, if Toronto is the capital of Canada, then Toronto is a large city. Yeah, well, don't tell me whether this is true or not, but this is how you would use the implication in a compound statement using this connective. So you can also use a biconditional. With a biconditional, you can say that P implies Q and Q implies P. You use the single arrow with two arrowheads in both ends. And again, there is English ways of expressing this. The one that is can be confusing is this. I've seen students making mistakes when they see this on paper. They sometimes they think it's a typo, so they assume that it's an F, and then of course that's not correct. So these are three different ways of denoting the double implication in natural language in English.